And up next, ladies and gentlemen, it's time again to have a very dynamic duo back on the stage. First of that dynamic duo is going to be Mr. Anubhav Singh, AI engineer at WNP, Google Dev expert of GCP and ML, a TEDx speaker and an author. Sir has over a decade of experience dealing with large-scale software complexities before embarking on his own AI startup venture. He has been a contributor to several open source projects and has authored over 2 books in deep learning on web and mobile apps. He is also a Google VMPS scholar. Ladies and gentlemen, can we have a big round of applause for Anubhav Singh, sir? And joining him is going to be...
We also have Mr. Ayush Thakur, sir, Manager AI Engineering at Weights and Biases. Sir is a machine learning engineer at Weights and Biases and a seasoned caggler and a passionate robotics guy. He has a background in electronics and communication and hence also has a deep-rooted love for math and physics. He has 6+ years of experience practicing machine learning. Our dynamic duo will be touching upon the topic AI Insights with Weights and Biases, with Weave, Weights and Biases.
So ladies and gentlemen, it is now the time to hand the stage over to them. Let us introduce them with a big round of applause. Zordar taaliyan ho jaye ek baar.
Hello. Can I just get a quick raise of hands so that, we are about to go into lunch, so I guess folks are tired. It was a long day. So like last 30 minutes, let's have the energy. We have a lot of fun things that we want to talk about. We will be sharing that with you folks. As they mentioned, I am Ayush. I am a machine learning engineer or an AI engineer, whatever you call it these days, working at Weights and Biases. So our session today is to talk about what Weights and Biases is, what we do. That's one bit. There are few educational content here as well to explain what are workflows, what are agentic workflows, etc. Once I'm done, I am going to be taking like 16 minutes, and then Anubhav will be demoing a very interesting stuff that you all can interact with, as well as a collab notebook. So, ready? Yeah. So a lot of talks today, you must have heard about agentic AI, right? Where folks are utilizing the power of large language models and large vision models to build systems which are intelligent in nature, right? So the intelligence bit are, they can figure out, given some input, what is the next task to do. They can select tools like, hey, do I need to do web search? Or do I need to find something from Jira? Or do I need to go to Salesforce to do something, right? So a lot of those intelligence can be now orchestrated or baked in using the LLMs, right? So you do not necessarily need to write if-else, right? A lot of the code path in software 2.0 used to be in that nature where you need to define the code path. That is not the case anymore, right? Having said that, a huge percentage of these agentic frameworks are not being able to go into production, right? They are just failing massively. I mean, there's this article that I found on Futurism like a few days back, right? It's from July 3rd this year itself, and it's saying that the failure rate of these agentic applications are absolutely painful, and that is true. And there are few reasons to that. One, obviously, that the LLMs itself, I mean, they are powerful, they are right there, but they still need a lot of massaging. And for a lot of niche use cases that we, as developers want to build, or as consumers we want to consume, the LLMs are not necessarily trained for those, right? They have, after going through the pre-training cycle, when you're training a model, you pre-train that, right? So after going through that, it has learned to generalize, yes, but not necessarily for many niche tasks. Hence, they are failing. But there's another reason for that as well, and that is lack of proper tooling when you are building those applications. Yes, I mean, the talk right before us, the mesh, right? It's a great concept. There's a lot happening, right? there are cloud providers, there's MCPs, there's multiple LLMs that can be orchestrated among themselves, right? But you need a tooling, that observability piece on top of everything that can enable you to build those applications in the best way possible. So that's what we do. So the problem statement that we are trying to solve is that, hey, it is very easy to build a demo today. Like literally you all can open up your laptop, fire up a collab notebook and build a demo. It's as easy as that, but it's really hard to productionize. We used to say the same thing back in 2017, 2018, 2019, when we were training models. Like training models is still easy, but putting them into production is hard. Now these models are in production, but now using them to build something is hard, right? Well, when it's agentic applications, it's even harder. Like it's far more harder than building a simple LLM or VLM-based workflow, right? So our mission is to build the best developer tools for AI, right? We have been doing this since 2016, right? And we provide the entire breadth and depth of tools, right? You can have, we have tooling for training, for fine-tuning, from prompt engineering or context engineering, building applications, agentic applications, we provide tooling for that. We have a huge list of enterprises. We are serving 1,300 plus customers, right? And all the big names that you can think of, OpenAI, Meta, Samsung, Salesforce, Adobe, Canva, you just name it. We are, I mean, they all are our customers. We are serving them with the tooling that they are using to build the applications that we folks love and enjoy, right? Yeah, we feel proud of that. And yeah, we are serving like 1 million AI practitioners. So if you are an upcoming AI developer, someone who is aspiring to be an AI engineer, learning how to use an observability stack on top of your application is important. And maybe you can try our tool as well. It will be a good thing to learn because that will enable you to build better applications. Cool. So here, I mean, in our head, there are 3 personas that we serve to. We have the foundational model builders. So these are the folks, these are the machine learning engineers who you must have heard news of were recently posts from OpenAI to Meta for 100 million USD. Right? That's insane amount of money. So these are those folks who are building those foundational models, name it GPT, you have Claude, right? You have like, there's Gemini, there's so many models right now. And almost every company or every AI lab that are training those foundational models, they are using weights and biases as the tracking observability tool to like do all the experiments, to orchestrate everything, and to like the MLOps thing, right? But here we are to talk to the AI engineers and to the software developers. Because AI engineers are those who are gonna be leveraging those foundational models to build applications, and software engineers are like, we see them using this stack as well eventually. All right, so these are the folks we are talking to. One sec, something happened. Yeah. So the path to building an application is not as straightforward as, I don't know, like writing a software 2.0 is still easy, but building an agentic application is not that easy today, right? There are 2 axes. On the y-axis, you want to do context optimization. Prompt engineering used to be a term back in the days, but it's not anymore because we have understood that, yeah, prompting allows these LLMs to like spit answer, but they are good at that. Like you ask it to write a poem, it will write a poem. Then the question is, when you ask it to write a poem about maybe a political leader, maybe a company, maybe a friend of yours, maybe a, I don't know, like a group, you need to provide the relevant context to the LLM to write you the poem that's actual, that's factually correct, that's relevant to your need, right? So that requires you to do a lot of context engineering wherein you provide the right context to the LLM, right? And there are multiple paths you can take to provide that context. On the x-axis, we have system optimization, right? You want to provide as much context as possible, but obviously you don't want to lower the you don't want to increase the latency, you don't want to take a lot of time, you don't want to make every like query to output cost way up. So yeah, we want to optimize a lot of these things. And as I said, the path is complicated. You might start prototyping by writing some prompt. So you fire up ChatGPT, you have some idea, you type in your stuff to see if it's possible, right? And then maybe you then add some few short examples. You then can maybe build a RAG pipeline to add simple retrieval on top of it. And then maybe you're like, hey, I want to improve the accuracy of my system. I want to make it better. And for some reason, you just go on and like fire up some GPUs to fine-tune a model, right? And then you realize that fine-tuning is an overkill for your use case. So you go back to do like a hybrid retrieval with some fact-checking steps in between, right? And then maybe you go all the way on other axes to start building an agentic system. So understanding what the right stack is hard because we are literally in the early days of building these applications. We are the ones who are going to be figuring out what is going to be, what's the best way to build an application. For a certain category of applications, what's the sure short way of doing it. So even though it's a mess right now, we are going there, but it's up to you to figure out, right? I mean, because I talked about RAG, so you can check out our RAG++ course, like a shameless plug. Yeah. So as I said, like on the y-axis, we had the context. Like I said, we need to optimize for the context, right? So context engineering is a lot of these things, right? Like user prompt engineering is obviously there. So memory is there. The system prompt is there. What are the tools you are providing the LLM to do a certain task? That is part of context engineering as well. So there's a lot of stuff that falls in the category of context engineering, and it's up to you to pick and choose, right? Yeah. So yeah, bottom line, it's messy. Yeah. Before I go ahead, the reason I kind of talked about this to set a ground wherein I'm saying that, hey, building agentic system is not as straightforward. And it was also highlighted in previous talks as well. It's messy. The path you take to build an application, the stuffs you can do, like training a model or picking an LLM or like building a RAG on top, whatever, it's messy, right? So we need proper tooling on top of that. And that's the context I've been setting. And just to give an example here as well, with like a clear definition between workflow and agent. Why I'm saying so, today, we are at the point where we understand that for certain tasks, if we just ask an LLM with few enough tools and like few enough components, it can just achieve it. Wherein you have a clear code of like clear path of execution, right? You give a user query, you say that, hey, you enhance that user query. Then you say, okay, you retrieve certain stuff from that user query and then pass it to an LLM to generate something, right? That's a conventional chatbot. So if you look at this diagram, the arrows are all pointing in one direction, right? And we usually, and I like to call these workflows because you are defining a workflow. An LLM piece is sitting in between to do the retrieval, maybe to do the synthesis, etc., to do the query enhancement in this case. But there's a clear code path. But for agentic work case, if you look at this diagram, the arrows are pointing in both directions, right? Because for an agentic system, the idea is that, hey, I give you a task. Now you take whatever amount of time you want to take. You take as many LLM calls you want to take. You make as many tool calls you want to make. Just achieve that task, right? So that's the goal of an agentic workflow, and hence is bidirectional in nature. And hence it gets even more more messy and complex too, because you have to think about every component, optimize every single component, see if it's working, not working. You want to think of fine-tuning for like a small component. You want to optimize the whole thing end to end, etc. There's a lot going on here. So quite easy. You might, you even need observability for workflows, but you can like have a good POC, have an alpha release, go to a customer, talk to them, get some early feedback and improve on that. But agentic system, you need a tooling. Right, so that was the context setting from my end. Just to conclude everything with few slides stating how we are trying to fix the problems that are there when you are building an application like that. So we start with, so imagine this to be a life cycle of an AI engine, right? You have an idea, you experiment, you then prototype, you iterate on top of it, you have some application, you build evaluations around that, you put in some guardrails, you think that, hey, I need to fine tune something, you do that, and you keep on repeating this cycle till you have a product that you're very confident with, right? And obviously, even if you go out with a release, you wanna keep improving on that using this cycle or a subset of this cycle, right? So the goal that Weights and Biases is trying to achieve, we have tooling for the entire cycle, but as someone said, it's still something we all are figuring out. The whole agentic roadmap is something we all are figuring out together. So the toolings are developing as we are speaking, right? So we want to start with exploration. The idea is that, hey, you can go to ChatGPT, ideate something, etc. But it doesn't allow you to tweak the temperature of the model, to set top K or top P. You do not have those controls. So you ideally will go ahead and build a playground for yourself or use an SDK, right? So we built a playground for that. So we built a playground for that. So this is part of our tooling stack. When you sign up, you can see this playground as well. So here you can select the language model you want, and we have all the language models integrated with us. So select one, select the hyperparameters for that model, like the temperature, the top P, the frequency, etc. And you write in your query, keep iterating on that, right? And you can do a lot more fancy stuff. You can set up number of trials. So for the same input, you can select multiple combinations of hyperparameters, and you can literally have multiple trials of that, right? And that will help you build an eval data set as you go about iterating your idea. So this is very cool. So this is one thing. Other thing you can do with the playground is you can compare between different models, right? Because there are so many LLMs out there, and you need to optimize. There are trade-offs for everything. I guess yesterday or day before yesterday, Grok 4 came out, right? And they are really topping the benchmarks. Maybe Grok 4 is for you, or maybe it's not, but you need to experiment that, right? Just because it's really doing well on some public benchmarks, that doesn't necessarily mean that it will do well for your use case. So you need to experiment, right? We also launched our model inference service. So if you want to get access to open models like DeepSeek or MetaLlama or Mistral, whatever, you have through our inference service as well, which is cool, right? So we have the whole stack. We have the playground wherein you have the access to all the proprietary models. Obviously, you need to put in your own API keys, but you can also have these models that we have hosted, right? And then you prototype. Now, prototype requires a very key component, which is tracing, right? So when you are building an application, maybe writing a piece of code in Python, and there's an error, right? You get a trace back. So you can literally go line by line to understand where the error happened. Same thing is required for these applications as well. And moreover, because you are not 100% sure what exact the code path is going to be, right? Is it going to select the right tool? If it selected the right tool, did it select the right parameters for that tool, right? There's a lot of nuances that are in play, so you need proper traceability to understand what is happening when. And this, we have the traceability baked in, right? And I will talk about quickly how easy it is to start using this feature, right? But the point is, you need traceability, and it allows you to understand the entire flow of your application and help you debug and optimize and whatnot, right? So starting is literally few lines of code. You need to install our open source Python package called Weave. Do pip install Weave. That's it. You do import Weave, Weave init, and just decorate all your functions with Weave op. So if you are a Python developer, you know what decorators are. I guess decorators are a quite it's a CS thing, right? So you know what decorators are, just use that, and you can start tracing the functions that are important for your applications, right? This is great, but in many more cases, you don't even need to do that because we have integrations with all your favorite frameworks, be it OpenAI SDK, or be it DSPY, or Llama Index, LangChain, CrewAI, ADK, MCP, you name it, we'll have an integration with that. So in most cases, you don't even need to do that decoration of your function, and we will just trace everything for you, right? And the tracing also gives you like token count, cost, latency, and everything, like off the shelf. You don't need to write any piece of code for that. Great. Some views to understand what's happening in your application, the tree view, the code view, the flame chart, etc. These are like additional features for you to understand how your application is operating. Right. The final piece that I will touch upon is this iteration. And the underlying essence that I want to just highlight here, because it itself is a huge topic to talk about. But the point is, if you are building an agentic application or any AI application for that matter, if you are thinking that, hey, I will do evaluations later on, you are at loss. You will never have your application on production, right? You need to start thinking about evaluation from the get-go. Evaluation is a feature of your application, so think about it thoroughly, right? And again, I don't know, yeah. So yeah, we have tooling for that as well. We can do a lot of interesting graph visualizations and like comparisons between all the different evaluation runs. So it's really useful that way. Right, again, a shameless plug. And the reason I'm stopping here a bit is because evaluations is one of the hardest and the most crucial part of building any AI application, right? So maybe you can check this out. Right, I'm skipping like a few bits here because these are not important right now. The guardrails, like user feedback, through the like getting feedback from the UI, etc. They come in picture later on, but maybe fine tuning is something you get used to, right? You might need early on. So yeah, weights and biases has been an MLOps product for the long get-go. As I said, all the foundational all the foundational model builders have used weights and biases for fine tuning, training their model, so you can use that as well. Yeah. With that, I conclude my session and hand it over to Anubhav. Yeah, so the only point that I want you all to take from my section is that building an application is not as straightforward as you might think, and having access to a proper tooling is very important while you're developing a model, right? Yeah, over to you, Anubhav.
Yeah, less, do more, write less, do more. How many of you have any good example for this? Anyone? Okay, let me give you one. I think a good example will be this, right? What to do at night. How many of you have been here? No? Do you recognize this? Whoops. Yeah. I should have looked back. Okay, this is my extended screen. Okay, let me set it up. Yeah. Displays. Okay, good. Oh, lots of stuff open. Okay, yes. Right, write less, do more. And one of the examples which I have for this is definitely a nighttime plan for a lot of Punekars. Right, and I think I've already made this joke, so here we go. And the idea is basically that you should be able to use less code to mean more, to convey more, to do more, right? So that's the idea. And see, as a lazy developer, I like that, right? How many of you are lazy developers, right? Backbenchers. People in the backbench are like, hey, it's me. Look at me. I didn't even take the effort to come to the front, right? So yeah, true lazy developers, right? So I'm one of them. And I don't like libraries or frameworks or tools which make me do the hard work, right? I want things done quickly. And that's why we have a 3-step process for integrating Weave with any of your Python ML training pipelines, or even just a normal Python code lab, right? And while you can scan this to get the idea of what I'm trying to reach eventually, I'll give you a walkthrough example as well, because I know a lot of you are not scanning, right? So here we go. Let me show you some good stuff, not this, right? So, okay, so here's some code, right? UV pip install Google Gen AI. How many of you have used this particular library? Google Gen AI, lot of you. Okay, so people who have used Gemini in general, right? And then there is some magic framework, okay? Some magic framework. I don't know what it does. I'm just using it as a consumer, right? How many of you use such magic frameworks which just get things done? No AI developers here? LangChain people. LangChain. Raise your hands very high. I need to see this. Yeah, 2 or 3 people. Okay, Google ADK. No one. Oh, someone in the back. Okay, MCP. Some of you, although it's not a framework, it's a protocol. What else? Crew AI. Okay, very few. Nice. Anyway, let's try to understand this. So I'm assuming that a lot of you are not working with AI frameworks, and let me tell you what happens. Right? There's so many frameworks in the market these days, and what they are doing inside, people are not really aware. Right? And that is why when it makes surprising outcomes, when it gives surprising outputs, the developers get under fire from the management. Right? So let's say you are one AI app developer, you are trying to build an AI app, you are using one such magic framework, and you just import call from it. And the question is very simple, right? What color is the sky? And what should be the output? Blue. How many of you vote for blue? What about the rest of you? What sky do you see? Red? I see. Okay? But the output is not so, right? Yeah, for those of you who got the context, it is this slide and then this, right? But for those of you who do not, it's a great movie. The movie's name is Coco. You can go and check that. But yeah, I mean, how do you solve this, right? Unexpected output. Unexpected output. How do you know what happened? How do you figure out what caused the crash? How do you figure out how was your user able to get the data of other users, right? So it starts with something as small, right? And to do that, let me show you a very simple few steps. First of all, let's go ahead and install, not the magic framework, we have already done that. So we are going to install Weave, right? The tool name is Weave. And anyone who does not understand what is that UV? Okay, it's the future of where pip is going, right? So your pip install might take a lot of time, but this does not, right? So I have installed Weave, and after that I need to import it, or rather, let me actually import a few things, which I'll show you what they do. For those of you who are familiar with Colab, you know that import OS is just importing the operating system utilities, and then user data is provided by Colab itself for fetching the keys which you have stored in Google Colab, right? And then you set that particular key to the environment. So this is what we are doing. It is the equivalent or the forerunner of using .env files, right? So my key is in that. That done, now I can go ahead and import Weave, right? So I have imported Weave, and the next thing I'll do is weave.init, right? So far, besides the importing of the env file, the amount of things which I've done is basically pip install, import, and init, right? So let me just do it ccd Pune 25. Right? And let me just run this one more time. And this time, although the output is still the same, I get a URL, right? And what does this URL contain? So I did not set up to provide this URL. I did not change anything as such, right? I just did weave.init. And this URL gives me everything I need to know about to debug this particular API call. And if you see, this was the API call which I made, and it took 403 milliseconds. Let me zoom it a bit. It took 403 milliseconds, and it costed me some $0.0001 because the costings and what were the amount of tokens used, input, output, all of that is visible. But the more important part for me, which helps me with the debugging, is that on the right side, you can actually see I'm just calling this. I'm not even passing the prompt, right? So that is what makes it give that output, because I'm not actually passing the prompt. And I'll show you what the magic framework does. And it's just this, right? So all it needs to do is say this particular output, right? So I created a problem myself. I solved it myself. Great, right? But yeah, you get the idea, right? Your framework might be doing something like this. It might be adding hidden system prompts. And sometimes you will run into problems. And this is when something like this will come really, really useful in solving it. Might also be that you might be building an application in which you have dynamic prompting, as in something which the user has set up, some configurations, some input which the user has provided. Based on that, you are making the API calls. You want to know how the user was able to produce, let's say, controversial content, right? So at that time, something like this will help you exactly pinpoint what happened. Plus, you can see the distilled code of whatever was used to produce this response, right? The absolutely distilled code among the entire tens of thousands of lines which you are using, you can actually boil it down to very few lines to understand what exactly happened here, right? So that said, you can also provide feedback whether the output was good or bad. That is up to you. And you can also completely replicate the whole thing by simply doing something like this. Call is equal to get client.getCall, and you fetch this particular call, you test it. So you can also set up automated testing on each of the API interactions which your users are doing with your AI application. Now, there's a lot of things to explore. Ayush showed you a lot of charts and stuff. Feel free to play around on this dashboard. But before that, feel free to play around on something which we are doing just there. So introducing to you a game called WeaveDraw. In WeaveDraw, you will see a target shape on the screen and a prompting input below that. You have to provide the prompt to generate that target shape, right? And there's actually 10 levels, and there's a public leaderboard, right? And how you start playing it is by putting your WANB API key. Let me show you how you can do that. So this is the interface. Click on authorize on the top right. On mobile phones, you will see it still on the top right. And then there's this get your API key here. Just click that, and it will take you to weights and biases. If you do not have an account, it will ask you to create an account. And if you do have, then you will see a UI like this. Just copy this, bring it here, paste it, and you are good to go. Right? So you just need to click Save API Key, and it will show authorized. And since I've already played the game, it is showing me my current status. But if you're starting new, then you will be on level 1. And let me actually show you what it will look like. And it's as simple as, let's say you have to draw a circle, then just type circle. And you should be able to get a decent circle. I mean, this is level 1. I want to hook you in. I want to grab your attention, right? So first level, very easy. Just type circle, and you will get bonus tokens, and you will go to the next level. The good thing is everything comes onto the leaderboard. And let me filter by date so that I can see that I have got some points here, right? And how do I know this is my username? On the playground itself, I can actually see that username here, right? And if you are on mobile phone, then it comes into a modal. It's modal like this, right? So yes, play this game, because we have a bunch of goodies out there. I think keyboard mouse combos, soundbar, right? So yeah, you can win those, and we will be providing these to the top 3, top 4 players of the game. So yes, please come to our booth outside, just on the right, play this game, right? And this is something which you can even play sitting here. You don't really have to come to our booth. If you do come to our booth though, we'll be able to help you with any of the problems. We might give you some hints to win this, and at the same time, you will get some very nice, shiny stickers, right? So, yeah, that said, yeah, you can get this slide deck, you can scan that, or if you want to scan it again, quickly take a photo. Right. Okay. Still the cameras are up. People in the back, if it's not coming into focus, don't worry, you just have to come to our booth, it's near for you. So that said, yes, to get the slide deck, you can scan this QR to get the whole thing. And do visit our booth. We are just outside, you will see me there, like this, right? So thank you. If you want to connect with us, we have the usernames on Twitter, Ayush 0 and Experian. So that is it. Thanks a lot.